PicoScope 7, relative compression using voltage and amperage with a cylinder sink. Pico version 7.1.5.15549. This video is sponsored by AES Wave. The engine relative compression test does not provide a compression value for each cylinder, but instead it is a comparison of compression between all the cylinders. This is a fast way to identify mechanical compression problems in an engine that is running poorly. An oscilloscope is required, and this can be done by measuring starter amperage per cylinder or battery voltage reduction per cylinder. The starter amperage will rise on the compression stroke, while the battery voltage will drop on the compression stroke. This training video will show you both methods, including how to use the sync signal to identify each cylinder. When starting Pico 7 software, it will auto-detect the Pico Scope and load the default settings. If you have a 4425A Pico Scope, it will auto-detect the probes. Here we notice that it detected both channel A and B as voltage probes. Opening each channel and selecting the Probe tab confirms this. Channel A will be used to capture the relative compression waveform using voltage changes that are caused by amperage changes that result from compression resistance. Set the voltage to plus or minus 2 volts. Coupling is set to AC and turn on invert. Select the DSP tab. Turn on low-pass filtering by clicking Active and set it to 3000 Hz. Select the Display tab and set the offset to minus 10%. This will make it easier to interpret the waveform. Channel B will be used to capture the number 1 cylinder trigger in case we need to compare the waveform to the cylinder firing order. Set the voltage to plus or minus 5 volts. Please note that 5 volts is only used for a digital trigger. This is typically identified for any coil-over plug system with 3 or more wires connected to the coil pack. The setup for primary or secondary voltage sync is not covered in this video. Leave the DC coupling on. Bandwidth limit is off and invert is also off. Select the DSP tab. Turn on low-pass filtering by clicking Active and set it to 3000 Hz. On the Display tab, leave the offset to 0. Set the time base to 200 milliseconds per division. Click on the Sampling tab and make sure Sampling Rate is selected. I use the target rate of 1 million samples across the screen as compared to the normal default of 2 million samples across the screen. Turn on the trigger. Set the trigger to single. Set the type to simple edge. Select B channel and set the threshold to a positive 2 volts. Set the pre-trigger to 20% and the direction to rising. Here's a bonus tip. This setup can be saved and recalled anytime you need it. To do this, click Save from the menu bar, select File Type and choose PS Settings File. Click Browse above the folder location and navigate to your Documents Waveform folder. If you don't have a setup file folder, click on New Folder and create one. Select the Setup Files folder and type in the file name that represents the saved settings. I'm calling this Voltage Relative Compression Sync. Click Select. Change the A channel label to Relative Compression Voltage and select Unknown. Change the B channel label. Notice that my system had a number 1 cylinder ignition sync as an option. I'm editing this to ignition sync because I don't know if I'll be able to sync off of cylinder number 1 every time I perform this test. After editing the name, click the plus sign icon. This label will now be available for future channel labels. Make sure Unknown is selected. Leave everything else blank and click Save. Closing and restarting the Pico 7 software will once again start up with its default settings. From the menu bar, click Open. You can choose the preset from the Recent Files menu, or you can click Browse and navigate to the Setup Files folder and select the relative compression voltage file and click Open. The entire setup configuration is loaded and you're ready to go. For this demonstration, I will use an amp clamp to capture relative compression with amperage so we can compare the voltage and amperage waveform. Because I'm using PicoScope 4425A, it will automatically detect that I have plugged in my amp clamp. However, I still need to configure it. Set the amperage to plus or minus 200 amps. Notice the bandwidth limit is active at 20,000 Hz. This is recommended and it will help to remove excessive noise that is often associated with inductive amp clamps. On the Probes menu, I can verify that the correct probe has been selected. Leave the low-pass filter off and leave the offset at 0. Channel C is now displayed in green. However, for this demonstration, we will only use amperage waveform as a comparison. So, I'm selecting the View menu and I will turn off viewing of the C channel. We can see that the C channel is still active and it will still capture the amperage waveform. However, it won't show on the screen until I return to the View menu and turn viewing of channel C back on. Connect the positive and negative battery clips to the battery. Connect the blue Pico lead to the red clip and the black Pico lead to the black clip. Connect the other end of the Pico leads to channel 1 on the Pico Scope. Using the wiring diagram, you can see the ignition trigger for number 1 cylinder, IGT1, is a red wire with a blue tracer or stripe. Connect the back probe pin to the PicoScope lead. Back probe the red and blue wire on cylinder number 1 coil. Connect the other end of the Pico lead to channel 2 on the PicoScope. I'm using the Pico TA388 amp clamp. However, other high amp clamps will also work. The arrow on the clamp indicates the direction of electron flow, which is negative to positive. I'm putting the clamp over the negative cable because it is easiest to get to. You can use the positive cable if it is more accessible. Just make sure to clamp over all cables and not just the biggest one. For this test, I will point the arrow towards the negative battery terminal because I want the pattern to be inverted. Connect the other end of the amp clamp to an open channel on the PicoScope. Disable the vehicle so it won't start. It's preferred that the fuel system be disabled by pulling a fuse or a relay or by unplugging the injectors. Try to leave the ignition system active for the cylinder sync signal in case you need to identify one or more cylinders with low compression. During cranking, a waveform of voltage fluctuation is captured. With uniform voltage changes, all the cylinders are close to being even. This engine does not have any cylinders with abnormal compression. Nothing more is needed. However, if you look, I'm still capturing cylinder number 1 ignition sync on channel B and relative amperage on channel C. From the View menu, turn on to view the B channel to see the sync waveform. Use the zoom tool to zoom in on one full 720-degree engine cycle. Let's compare the amperage waveforms by turning on to view the C channel. The first thing you might notice is the amperage waveform and the voltage waveform are opposite. This is because I did not invert the voltage waveform before I cranked the engine. Return to the A channel settings and under Invert, click On. It's now obvious that the voltage and amperage waveforms are almost identical. The sync signal and the firing order can be used to identify the cylinders if there is a problem. For example, this was captured on a vehicle using the high voltage spark plug wire to sync cylinder number 1. The spark plug was removed from cylinder number 2. The rising hump from cylinder number 2 is completely missing due to the missing spark plug.